Okay, guys, so Calc Foundations. Let's begin. Chapter 2.1 is rates of change and limits. I'm going to make this into a two-part video because these notes for section 2.1 are kind of long. Alright, first off, we're going to start off with some vocabulary. So, average speed, you guys have probably done this in physics, but we know that average speed is equal to distance over elapsed time, aka change of x, okay, change of the distance, over change of t. And of course you know that the units of measure are going to be kilometers per hour or feet per second, meters per second, okay? Now instantaneous speed is going to be the speed at one specific instance. So for example, if we were to say at t equals 2, okay, your instantaneous speed is going to be a very small moment in this t. So you'll notice when we do a problem, we're going to end up saying that if we're trying to find the instantaneous speed at t equals 2, what we're really trying to find is t equals 2 plus some h. And h is going to be our very small moment. A very small moment in t. Okay? Now the distance equation may or may not come into play right now, but it's something that you guys should recall. And if you remember that the distance equation, you're probably going to use this in your homework, in the homework problems, is the square root of x2 minus x1 plus y2 minus y1. And that's basically if you're trying to figure out the change in the distance where it is not going to be directly on x. So let's say you're trying to figure out the distance from point A and then point B is going up diagonally. Alright, so let's do a little example. So finding the average speed, given that solid objects drop from rest fall freely near the surface of the earth at y equals 16t squared in the first seconds. Find the average speed during the first 2 seconds of fall of a rock that breaks loose from the top of a tall cliff. So we know that y equals 16t squared, and that's in feet. In the first t seconds. So basically from t equals 0 to t equals 2. So the way we figure that out is our change of y, okay, which is going to be our change in feet, is going to equal 16 times t, which is 2 squared, and then minus 16 times 0 squared, because it's starting off at 0 seconds, and that will give us 64 feet, and then our elapsed time, our change in t, is going to be 2 minus 0, so that's 64 feet per every 2 seconds. But of course you always want to simplify this so that your unit is just feet per second. And of course, 64 divided by 32 by 2, is 32 feet per second. So this is our average speed of a rock that falls, given this equation, given y equals 16t squared. Now to find the instantaneous speed is a little bit, this is kind of where the calc comes in, but first I'm going to show you the algebraic way to solve it, and then we'll come back to the calc way. So instantaneous speed, remember, is at t equals 2. So really what we are trying to find is where t is equal to 2 plus h. And remember that h is a very small moment in time. So it's going to be 2.01 or 2.001 or 2.0001 and so on and so forth. So our instantaneous velocity is equal to the change in y still over the change in t. And the reason I'm using y is because our equation up here is set as y equals rather than x equals, but still the same exact thing. And because it's a falling rock, so a rock is not going to fall on x, it's going to fall on y. Now, the way that this is going to get set up, it's going to be 16 times. Now, our new t is a little different. It's 2 plus h squared minus 16 times 2 squared, because the instance is between 2 and then 2 plus some very, very small moment in time. And then all of that is over the change in t, and the change in t is going to be that very, very small moment in time, which we are going to call h. Okay? So I'm going to do a little note here. Okay? We can't really use the formula. We can't solve out the formula and solve this, because if h equals 0, what's going to happen to this whole entire formula? It's going to become undefined. So we can't use the formula and just solve it out to find the exact speed, because if h equals 0, then it's undefined. But we can get an idea as to what's happening. We can get an idea as to what's happening around 2 seconds by finding the formula as h approaches 0. So to get an idea, we want to find the formula as h approaches 0 seconds. Okay? So really what I'm going to do algebraically, because technically you guys don't know how to solve limits yet, but once we learn about limits, this is going to be a very, very easy problem to solve. So when we graph the function, so the graph, I'm gonna use the table. All right, and when you graph the function, I apologize, I don't have my my graphing calculator to show you this function so that I can pull up the table, because I did it on Desmos and you can as well. Okay, my h is going to be on top, and then of course my velocity is going to be on the bottom. So when h is 1 in the formula, plug in 1 into this formula and you're going to get 80 feet. Now when h is 0.1, you plug that into the formula, okay, and you're going to end up with 65.6. When h is 0.01, it's going to be 64.16. If it's 0.001, we're going to get 64.016. So you start seeing kind of where the limit is heading. So 0.0001 is 64.0016, and etc. So what do you notice is that as h is getting closer and closer to 0, our change in y, or our velocity, is going to be about 64. So velocity has a limiting value of 64 feet per second as h approaches 0. But h never becomes 0, because if h is 0, then this whole entire problem is wrong. So the instantaneous speed at t equals 2 is 64. Now, you tell yourself, okay, if I would have just plugged in 2, I would have gotten that same exact number, but you'll understand a little bit more once we actually start doing limits. Alright, so moving on. Definition of limits. Now, the definition of the limit, you guys already wrote this down from your own textbook. Okay, so I'm basically just going to write down the gist of it. Okay, the function f. So a function f has a limit, we're going to call it L, as x approaches c, okay, given any positive number, given any number c, and the way that this is written, okay, I'm not going to give you the big full thing of it, because the actual definition of a function just says that the limit as x approaches c, a number, there's a positive number for all x's. So f of x, the function f of x, is equal to that limit. Alright, it'll make more sense when we start actually doing some equations. So a function has a limit L as x approaches c. Okay? Now there's two types of limits. There's a right-handed limit and a left-handed limit, and this is pretty straightforward. Basically, for all limits, you're going to always look at both sides. So if I say x is approaching c from the positive side, then that function has a set limit. Okay, so the limit of f has a limit from the right. So we're going to be looking at it from the right. So I'm going to show you guys a little example. I'm going to draw a graph. I'm going to make an asymptote right here. And I'm just going to draw a random graph. So here, the right-handed side is going to be coming from the right hand. So the way that I would write this is I would ask you, what is the limit as x approaches 2 from the right side? We use this little plus sign to show from the right side of this function of f of x, whatever this function is. So you would just basically ask yourself, okay, as I'm approaching 2, so here's 2. As I'm approaching 2 on this graph, what's happening to the function? Where is it going? It's going up to positive infinity. So this right here, this part is called the right-handed limit. Okay? Now, the next part is the left-handed limit. It does the same exact thing, except now we're going to approach the function for c from the left side, from the negative side. Okay, so the way I would write that is the limit as x approaches c from the left for f of x will also give us a set limit. So the limit of f as x approaches c from the left is L. So looking at this function right here, I would ask you the same thing. So what is the limit as x approaches 2 from the left side of this function f of x? So you would follow this function from the left. So starting from the left, you would follow this function and you would say, okay, as I approach 2, as I get closer and closer to 2, what's happening to this function? It's going up also to positive infinity. So this is called the left-handed limit. Now what's important about these two is the following. Now a two-sided limit basically is just putting, I'm not even going to write anything for this, it's putting these two together. So it's using the left and right-handed limits. And the reason we need to do that is so that we can identify the actual existence of a limit. Because the existence of a limit tells us that for the limit of x approaching some number c of f of x to be L, okay, if and only if the left-handed limit and the right-handed limit are equal, if and only if the limit of x approaching c from the right gives us the same exact value as the limit of x approaching c from the left. So these two have to be equal for the actual limit to exist. So, going back to our original example right here, since the limit of f of x as x approaches 2 from the left and the limit of f of x as x approaches 2 from the right are both the same, they're both infinity, therefore the limit exists. So the limit as x approaches 2 from anywhere, both sides, the two-sided limit of f of x is infinity. Alright, so I'm going to show you an example of it not working. So I'm going to draw another random graph, and I'm also going to approach 2. So here's 2. We'll do one side going up like this, and then let's do an open circle, and let's make this graph go. Do one of those. So here's my question to you. What is the limit as x approaches 2 of this function? And the only way you can figure this out is by figuring out both the left-handed limit as x approaches 2 and the right-handed limit as x approaches 2. So here, the left hand, so the limit as x approaches 2 from the left of this function is what? So what is happening to this graph as x approaches 2? It is approaching 1, 2, 3, 4. Okay, so the y value is 4. And then from the right, the limit as x approaches 2 from the right of this function f of x. So from the right, where am I going? I am going all the way to 1. Okay, so you notice that, you're kind of walking on the x, but your answer, your limit is going to be where the function is on y. Now, because these two do not match up, then the limit as x approaches 2 does not exist. D&E, okay? It does not exist. Alright, so moving on. I'm sorry for the zoomed in, but if I try to zoom it out, it's going to stop the video, and I really don't want it to do that right now, because we are 21 minutes in. So the properties of limits, again, a lot of the same stuff that you've done with previous properties, it's just now it's a limit. So the idea here is that if you had a limit that approaches c of some function f, and that equals L, and the limit as x approaches c of another function that equals m, then the following applies. So for the sum rule, the limit as x approaches c of f of x plus g of x is equal to the sum of their limits. Okay? Same with the difference rule. The limit as x approaches c of f of x minus g of x is the difference of their limits. Same with the product. The limit as x approaches c of f of x times g of x is the product of their limits. Now the constant multiple rule just basically means if you have something on the outside that's multiplying your function and you have to find the limit of that, so the limit as x approaches c of some k of something times a function, then its limit is going to be whatever the limit of this function is, so L times whatever is being multiplied times k. Alright, now the quotient rule, the limit as x approaches c of f of x divided by g of x is equal to the quotient of its limit, but of course m cannot equal 0 because if it is, then this whole thing is undefined. And then the power rule. If you're trying to find a limit of a function that is raised to some power, okay, then its limit is equal to the limit of this function. So you find the limit of this function, and then you raise your answer to r divided by s, to whatever the power is. Alright, and we'll put that into practice in just a second. Alright, I'm going to stop here. This is part 1. It was basically like just the definitions with explanations. Part 2 will still be part of your video notes, but we're probably going to take an extra day with section 2.1. So make sure to watch part 2, at least start half of it, and then finish it off some other time. We'll talk about it tomorrow depending on how much we finish in class. But part 2 will be uploaded along with this one. Alright, see you guys in part 2.